Thank you. So hello everyone. I'll be today's talking head or the slides narrator if you prefer. And hopefully you'll forgive me for not being there with you, but I've been traveling a lot for the past couple of months and I kind of got homesick. So let's hope that internet connection serves as well and you get to hear and see what I've prepared on the subject. So just let me try changing slide. Okay, that's kind of working. So my name is Nikola Paunović and I'm a web developer here at Blueberry. And I'm also a psychologist, but I've been flirting with computer programming throughout various stages of my life and eventually made it a career. So one of the things that attracted me to Blueberry was the opportunity to work with these new exciting technologies. And that was exactly what I got since joining the company in May this year. So today I'll share experience of me and my colleagues of developing a real-time web app in Reason, and you could possibly draw some conclusions about whether we need this S in parentheses in the title. So the plan for today is to say a few things about the thing that we built, about the technologies that we used, what are some of the things that we enjoyed developing in Reason, and what are some of the things that we really didn't enjoy much. And also, I'd like to sum up with a few lessons that we learned during this journey. So, slides aren't listening to me. So what have we built? Well, we built the planning poker app. I guess everyone's familiar with the concept, but for those not being in the loop, here's a quick Wikipedia abstract that says that planning poker is a consensus-based gamified technique for estimating effort or relative size of development goals in software development. So in practice, that means when the user comes to our app, he or she can register and then gets to choose between one or three different roles. So one can be a Scrum Master, a developer, or a product owner. And Scrum Master is someone who can create rooms for votings, who can create new votings and invite people to vote, and can also finish voting when everyone has voted and display results to everyone present. Developer is someone who can just join, cast their vote, see when others have voted, and when the voting has ended, see the results of everyone, while the product owner can only join the voting and observe the voting process. So to show you this in the browser, hopefully you can see the two windows. It's going to be a bit tight because this is not like a real world scenario. So I'm going to try to create a few users here so you can see how that works. So we can create this user that will become a Scrum Master later on. We can have one developer here, and here in Safari we can have, for example, another developer. So now the user who will become Scrum Master can create a new room. Let's call it a new room. And he can choose between different card sets and cannot choose the role because only Scrum Masters can create rooms. But anyhow, when the room is created, you get this spin here. So other users can use it to join the room. So for example, this user needs to enter, so 49790. And you get this user there immediately. And also you can join another user. So you get 49790. Hopefully that works. Okay, so now we have three users in the room. And the Scrum Master can start the voting. And now when the voting is started, the users can vote. You can see that the first user has voted. The second user can cast his vote. And now the Scrum Master can finish the voting and everyone can see the results. So that's like the core functionality of the application we built. There are some more things to it, but this is the basis and the heart of it. And which technologies have we used to build this? As Ondra already mentioned on his presentation, we've used Elixir's Phoenix framework on the backend. And we've used ReasonML with ReasonReact and some of the tools from the JavaScript ecosystem to build the web frontend. And we also have a native iOS app that is connected to the same backend and is playing well with the web frontend. So you can basically vote on the same things either through the native app or through the browser. So first things first, I would like to say a couple of words about Reason. So Reason is actually not a new language. It's just an alternative OCaml syntax, which is meant to be more approachable to JavaScript developers with its C-like syntax. And it can be also compiled to JavaScript via BuckleScript compiler. And since it's just OCaml, it can be compiled to native code as well. So you get to share parts of your code base if you're developing for multiple platforms. But in case you're not doing that, why would you care? Well, they say it's writing React as first intended. And as a matter of fact, React was initially developed in standard. And later on, is everything okay with the sound?
Yeah.
Okay, so yeah, as I said, React was initially developed in standard ML and was later ported to JavaScript. And many of the things that people love about React and that made the React so popular and successful come from the world of functional programming, which is JavaScript supporting only partially, and the rest of the things are kind of forced into the language and are there by convention or by using some third-party libraries. So Reason, we together with the ReasonReact library promise to give you everything out of the box, so you no more need third-party libraries for immutability and static typing. You don't need external router. You have like the prescribed code formatter, and you have much of the things from the utility functions that are built into the language. And also Reason is backed by the big players such as Facebook and Bloomberg, so that promises something since they're using it in production, and it tells that this project could possibly live for a couple of years at least. So we'll see about it. And here are some of the things that we really liked about Reason. I'm gonna go through each of those and say a couple of words about it. So static typing is great, and in Reason you actually get the type inference for free. So you can actually just write your code and the compiler will infer types for you, and with the help of a Visual Studio Code add-on you can actually see the types in the editor, and you also get these nice errors if you try to pass something that function doesn't expect. And the thing is that even this type system from OCaml is actually much more strict than in TypeScript or Flow, so you can actually cheat less, and even with less boilerplate, because you don't have to define types explicitly all the time. Also, mutability is one of the core principles of React, is available by default in Reason. Everything's immutable, and you can mutate stuff if you really need to, but you have to be really explicit about it. And also, all the functions are automatically carried, and that makes composition easier. It promotes code reuse, and you can build some abstract functionality that you can further specialize down the road by partially applying the functions. And for that, you don't need no more neither immutable JS or Lambda. So that's kind of cool. And pipes are great. We really enjoyed them. So those are just like syntactic sugar. And basically what pipes do, it's like they take the result from the previous function and they put it as a last parameter to the next function in the pipeline. So here you can see these two snippets that do exactly the same thing. So they take this string that has date, which is formatted in a specific way, and they're splitting it on the dot and popping the last element, deoptionalizing it, and converting the string to integer. So, but if you look at the left side, you can see that with pipes, it's just like written as you would think about it. And on the right side, you have all these parentheses and you have to kind of read backwards. So yeah, pipes definitely improve readability in Reason, and a really great thing. And also one of the key selling points for Reason was the reuse of already written JavaScript code. So you have this promise that you can just like bind things by defining their types, and you can call them from Reason, already existing JavaScript libraries or the other code that you've written. So we've done this for the pin input you've seen on in the demo on the browser, and it was like really straightforward. But we also had this thing, since we have this nature of the application, we saw an opportunity to experiment a bit with reactive programming libraries. So we decided to use Most.js, which already had some bindings for BuckleScript, but as it turned out, we needed some additional functionality. So we had to bind some things ourselves, and that was a bit more challenging, but in the end, pretty doable, and it kind of lived up to the promise it gave. So this is a big plus for Reason. So you can, because you can gradually convert your code base. We didn't do that. We were writing it from scratch, but still we could use the things that other people have written. And beside those good parts, there are also some bad parts and some things that we didn't enjoy that much. For example, documentation is really good in some cases, and you can find a lot of the introductory material, but you have stuff written in the ReasonML docs, and you have stuff in the ReasonReact docs, and you have some stuff in the Buckle script, which is a completely different place. And also for some problems, you can't even find any documentation, so you have to dig deep into Discord conversations and try to find some answers or ask questions. And the community is rather small, so you don't get to just paste your error into Google and to benefit from the experience of other people that have faced similar problems. But since more and more people are using it, hopefully this will improve in the future. Also, we had some issues with Buckle script versions because we wanted to update our Buckle script version to the latest one, but some of the third-party libraries that we were using were stuck on the older ones, so it kind of fell apart. So we needed to revert back for everything to make it work again, and that wasn't nice. But hopefully, as the community grows and if these things gets to live, I mean, then probably we'll have more people maintaining stuff, and then we'll get to avoid these kinds of errors. So another thing, Reason scripts was a very big headache. We initially started using it, and then, yeah, that's like an analog for create React app. And it's supposed to give you everything to start with. And we started using that, and it kind of worked. It was nice, but then we wanted to introduce some testing, and there's still open issues. So Jest is practically unusable in the world of Reason scripts. And also this thing with end of file error was pretty annoying. So from time to time, and it was becoming more frequent each day, we would get this end of file error, and you would save a file and it popped again, and you need to save a couple of times to get rid of it. And it was like making us all go nuts. So in the end, we ditched the Reason scripts altogether and baked our own solutions. So it's working now, but that's just like a friendly warning for anyone trying to do something in Reason. Avoid Reason scripts, at least for now. Also, decoding JSON can be cumbersome. I mean, we had this experience. If you have like some nested data structures that have some optional or nullable fields, you quickly end up with lots of nested switch cases, and it becomes ugly very quick. So yeah, there are some libraries that can probably reduce boilerplate, but that kind of breaks the promise Reason gave us in the first place. That's the only thing that we need to develop. So yeah, I guess that something can be done differently and more easy with GraphQL, but we have yet to try that. And also, there's like no real consensus of how we're supposed to handle shared state between components. We initially started doing it with a component that was supposed to serve as a state provider. And then for some things, we moved away from it and tried using most.js observables. And it's kind of in the middle of refactoring, and we're trying to find the right solution for our project. But it would be nice if there was some kind of consensus and the general idea how these things are supposed to be done. And something about non-technical parts. Well, as any project, I suppose, this one also had some things that were not so related to the technology that we used. And in our case, for planning poker, there was this thing that initially it was just a small project that was supposed to be a playground for people to get introduced to Elixir and Phoenix, and it grew a bit over time. So it was kind of difficult to plan long term with this moving target. And also, since it's just a learning project, it always had lower priority. So people were constantly hopping in and out of the project and not really being able to focus all the time on it. So these are things that definitely made stuff more difficult, and they maybe even had a bigger impact than the technology we used. And the conclusion, the main conclusion from this presentation may be that there's no silver bullet, that Reason provides some great tools for some of the problems, but also creates additional complexity for some other things. And that in the end, the code quality and the maintainability of the code base is actually boils down to the experience of developers that are doing it, to their focus, to how careful has been the app planned and how well you design the architecture. So it's not all about the tools we use. And with everything said, I would like to say and stress out that I'm in no way a Reason expert. I'm just a regular user who had a chance to play with it for a couple of months. And so please feel free to correct me if I stated anything untrue about Reason or unfair at least. And also feel free to ask any questions if you have some, and I'll give my best to try to answer them. And thank you.